Okay, recording is on. So this is the first NooBaa Community meeting, and we are doing it as sort of a pilot to make sure that we can uh, get some feedback and value out of it. And if it helps us, we'll continue. If it doesn't, we'll stop. And in this session today, we're going to go over the PR by Paul. And also in the next meetings, we plan to go over more namespace features. And now we are in sort of the middle of working on the namespace cache project here. And Paul's PR adds a couple of things, and I'll let Paul introduce, and then we'll go over some comments and questions. And maybe just one last thing. We also have a doc to go over the meeting. Maybe I'll share it later when I share my screen. I just show it just before the end of the meeting, that like the structure, and maybe just that if you guys want to add to suggest anything specific for the calls, we can do it either on Slack. Either one that you can reach us would be good, and I'll update here, or you can make suggestions to the doc itself. So I'm going to post this, and I'm going to put the calendar link and the doc link somewhere in the project README, so that it will be accessible if somebody wants to join later on. And we'll see if we need more synchronization things here, if maybe we need more structure around it. But for now, I think we just want to get the PRs review sessions going. So Paul, take it for now and do some overview, and we'll start.
Sure. Yep. So this PR is regarding namespace caching. Specifically, is the PR is going to support range rate scenarios, and then a second part of the PR includes functional tests, which is functional tests also include the scenarios for regular reads or regular reads and upload, besides range rate scenarios. Okay. So in terms of design, just to give a summary and the highlights. So basically, the first point is range rate will, once it's triggered, range rate triggered, we internally we're going to cache fixed size of fixed blocks. Okay. What that means, like it could be if one basic block is like 4K bytes, depends on the size of range, the part to be cached could be a 4K or could be a multiple of 4Ks. Okay. So, but the size of parts to be cached, always a multiple of a block, basic block size. Okay. The block size is configuration parameter. Okay. Also, besides that, there is some optimization factors in there too. For one is, if an object is small, right, we actually going to cache entire object, even though it's triggered by range rate. We will not cache just specific that block size for range rate if object size is small. And then secondly, and also internally, we can switch between partial read and the entire read. And there's probably one concept we use is if you see the code, there's a partial object flag, which means like we don't have all the parts cached in the local. Okay. So But from user's perspective, based on user's operation in S3 operation, partial object can become a entire object, and entire object also become a partial. That's probably out of band scenario as well. So that means, like, for example, S3 client triggers, sends a range read operation. Then internally we cached the part for that range. Then if the client does normal read again, that we're going to cache the entire object afterwards. Okay. So that is also one of the scenarios. Another optimization scenario is if its object is super large, depends on how much we stored in cache. We can grab stream the data, some data from from cache, some data from the remote hub. Okay, so it's kind of mixed retrieval of data. So basically, that's pretty much the highlights of high-level points of this PR. And any questions so far? So if not, I can just quickly jump to the code to show you where the major.
So I suggest, yeah, exactly. So exactly what I want to suggest. If you can do something such as if you click on the file filter and unselect all the file types, you'll be able to collapse all of these file sections so that you can So untick all of these, like unselect all the types, even JS.
Okay.
And now the only thing that it does, it collapses, right? So you can now just browse through the change set files. So maybe just sort of give us some orientation. Where is the focus of the change, and maybe start with API changes. That will also help us.
Yeah. So the core changes is inside namespace cache.js file. Okay. Then next will be object IO. And then, as Guy mentioned, we also added a couple of new APIs for supporting range read scenarios. We also modified existing APIs for supporting that as well. So so before I dive into this main file, I'm going to just talk about the API procedures added or changed. Let's see, where's the...
So on the bottom is mostly tests and utilities. You'll find there, and if you stop somewhere in the middle, it will be also the API, object API, for example. Yeah. And you need to click the exactly.
So so first of all, talk about the API created, new APIs created. One is a start object part upload. Okay. That API is used to create a part upload. So like I mentioned, the part size or start end will be a multiple of a basic block size. Okay. So that one is going to store a part record in object in our database. Then corresponding to that, there will be a complete object part upload. It will be similar like the complete multi-part upload, but this is just once one part upload is created, this API should be called to to conclude the completion of the part upload.
So the first one second. So the first thing that I went through in the PR was the API, and the first question I wanted to try and answer here maybe is how much we need it, right? So we need. So I'm still looking for the motivation for the API and maybe to clarify it most, right? So I don't know. Maybe the motivation is strong, maybe it's not, but I'm mostly interested in getting to understand it. And once I do, I can reason about it and say, because it is a very internal API, of course, right, in this form. And we have a bunch of them, and the question is mostly about if we were missing an API. That's one. And on the other hand, we we already had some of these APIs as batches or as batch APIs, right? So the get mapping, put mapping APIs, which are the sort of analog APIs for parts, are using batches for putting new parts. So I was wondering when I was reading this if we can achieve if we can achieve the same using these APIs, or it will be too complex. And actually, this one is just the creation of the object or the part.
There's a part.
Maybe
it's a part. It's not creation of the object.
So it's for every part we need to call this one, right?
Yeah. Remember in the beginning when I prototype this, I actually used the multi-part API to do it. It will be similar, but the reason I guess we can reuse multi-part API, but by comparisons between my initial experimental changes and this one, it seems like this one is more cleaner to do. That's my.
No, I agree. I mean, so reusing APIs, it's usually less clean in one hand, but it's the premise or what I'm trying to achieve by looking at it is to see how much difference there is to the API, and if there is very little, I would claim maybe that there is less complexity when reusing, right? If the difference is creating more complexity, then of course I wouldn't to go there. But that's my first instinct, and I guess this instinct also, now that I think about it, the level of start. I mean, when we start object multipart, right? Typically, this is because we are writing large parts, right? In this case, which I would expect like a multipart to be. Well, it can be also 4 megabytes. Like a multipart can be 4 megabytes, but I wouldn't really expect 4 megabyte part. I mean, I think even 5 is the minimum from S3 perspective, and there's a tendency to use multiparts when you have larger multiparts, like each part as big. And in this case, we know that we are using 4 megabyte chunks, which is the caching granularity, and in this case we impose an update per 4 megabyte in this case, right? A separate one instead of a batch update. You see what I'm saying about the batch versus single part updates to the database?
No, not really. Maybe if you can
Okay. Yeah. So maybe the thing is this: in many of the cases that we send updates to the database, we batch it and then update as a batch to the database. We don't update per each one, and
you
this
mean
is actually
batch means like consists of multiple database operations, right? Is that right?
yes,
Okay.
yes,
Okay.
exactly.
Okay.
So if I want to insert, right, so I insert as a batch.
Mm-hmm.
And in most of these cases, what we do is insert, right?
Mm-hmm.
So we insert parts and we insert chunks. These are the metadata structures we need to create. And if we send it as a we get some latency back because of that batching, right? We don't need to use a lot of I mean, the latency that we get is for the aggregate. Not for the single operation, of course. And since this is a streaming operation, we can use some more for batching it. So the APIs that we have when we do the object IO writes, for example, are using the get mapping, put mapping sort of structure, and these go and do get mapping for all of the things that we like a batch of things that we have in memory ready to be written, and then we have a bunch of allocations being returned, and then we write to these allocations to the storage, right? And then we put mapping to insert all of these references to the storage. Okay, so but I think it's not concrete at this point because we need to go and look at the actual flow between object IO and object server, and then we understand. Okay, so what can we do? Can we actually how much reuse it makes sense here? So that's about the API. Other than this, I think the API it does look like in the same structure that we always create here, so it makes sense. But just in the semantic way of, do we want this API to be separate or not, right?
Yeah.
Okay.
So
I have a question regarding the API, if I may ask. So what I have is I just scrolled across the API, and I'm wondering, like you've said previously, that you currently call the start object part upload, and then after each part, you call the complete object part upload, which means that basically, if I will simplify this, it's like start object part upload will actually start, and the complete will do the complete like we do the parts in multiple uploads when we send multiple parts and we aggregate them to a single object. So in this case, you just mark a single part and complete a single part with the complete object part upload API, or am I missing something?
yeah, basically that's pretty much it. Other than that, it's going to summarize the upload size, number of parts there, going to return that.
But the number of parts should be one because you only upload one part, or am I missing something?
Well, depends on the range rate scenario. Like for example, client first rate, like rate from like 1K to 2K. Next rate will be like 8K to 10K, right? So that will become two parts. So will not so first rate will cost 1 to 2. Let's say if it's a block size is just 1K, right? So 1K to 2K get cached. The next second part will be cached will be from 8K to 10K. Okay. So once like for example, if if at the end of the second part read second read, so this complete multi-part upload procedure also returns your number of parts so at the moment. So that will become 2. Okay. It's not like a multi-part always. Once you do that, I believe it always 1, right? Once complete. Yeah.
Okay, I understand. So another question is regarding I understand regarding the complete. So the complete can actually complete multiple parts. But what I'm saying about another question is about the start upload part, start object part upload. I can see that you are currently returning the tier ID and the splitter encoder configs. But in theory, the tier ID what's the point of the replying the tier ID and if the tier ID can even change during the lifetime of the start object upload part upload? I mean,
yeah, that's a really good question. Internal. That's also one of the reason. I create a separate new API. If you look at the code, I can forget the details. It's different than because for one single object upload, right? I create the procedure will be start from create object upload. So that one actually returns those tier ID chunk split config, those configurations, but for partial object, right? The create object upload, that procedure, that it's not in the same flow of like upload the entire object. So that's
you're correct.
Yeah.
I agree.
Yeah.
So I agree, and I think so. There's a few things I have to say about this. I mean, I think we used to be more when we coded this flow that returns the information about different tier and different split config and encoder config to the endpoint for every object. That was from a point of view of the ultimate flexibility, that we would like to allow every object even to have differences in how we actually going to ingest this object.
Okay.
But still, this is usually not really affected by objects, by the object properties. It's mainly the bucket properties, and since this is the case, we already shared most of these things with the endpoint, so the endpoint can have this information locally as well. So this remains, I think, in one way, this remains a more flexible solution to ask, per object, what should we do, right? But it's not that if we don't do it, we will lose any capability at this point.
Okay.
So that's just one comment on that. On the other hand, I do agree that once we are issuing a read and from the cache, right, and we need to actually, and we have a miss and we bring from hub and we want to apply that to the cache, maybe it is a wise thing to have something in this context, at least once request for this object, give me the these configurations. But and this context is the read, right? So the context of the operation is the read operation, the read request, essentially. So I think this also has it has a way of, like, it has two options how we could also look at this if we want to reuse. That was what I thought.
Yeah.
Okay, so I think any other comments maybe on the API before we try to understand maybe if this API, how do we use this API, and how, or maybe the next phase can be actually to go through the namespace cache and then try to drill down from there until we see the API. Maybe that will be a good practice.
Another quick question regarding the start upload object part upload. I assume that the encryption is the same logic as we have with the SCCC and SCC encryption of S3, right? Which means that the bucket is saying that if it's encrypted or not, and we can pass the keys via the client and stuff like that, right? That's the same encryption value as we have in our S3 flows. Yeah.
I believe so. Yeah, I believe so. internally, you know, I treat it the same as create object, upload, return whatever it returns. Yeah, so you know, that's I
Okay.
think so.
Yeah. Okay, I assume that's what you did. So if that's what you did, then that's the same logic. Probably you just propagate it. Okay, thanks.
There is probably something misleading in encryption features when using on. I mean, there's a server-side encryption feature, right? And in this case, we have two different servers, and it might not be that the same encryption can be applied. Anyway,
This is
just
why
saying
I
that.
asked about this tag, because I mean it only adds more
This tag.
complexity.
So I don't think this tag is the blame. I mean this tag is just the API to the object server, right? So it's just for completeness. It makes sense that you could set it, or in this case, I think you get it. But in this, what we're looking. I mean, I don't know what you're looking at actually. I was looking at something else. So if you scroll to that, where's that? Oh, so it's here. I can see. Encryption. Yeah, so this is in the reply, right? So just returning if you have encryption
Yeah.
and configured. I think in any case the API enabling this in the API is, I mean, makes sense in any way. It's really more of a question of the namespace. How does that respond to encryption
Yeah,
headers?
this is what I've asked. So basically, yeah.
Yeah. So I don't remember if we have all that covered in any of our designs. Mathieu, do you remember what did we say about encryption?
You mean about encryption of secrets, like a key and stuff
About
like that?
right. So I mean the different SSE encryption types. Did we even look at that at this point? Maybe not.
No.
Okay. Okay. So I think it's okay. I mean, from the API perspective, it's okay. But if we just need to cover that in namespace in next PRs, right?
Yeah, so it's a to-do feature right now, right? You just added it to the API, and you don't have any backing to that. I mean, regarding code,
yeah,
right?
Right. I think the API should have it. If that's the case.
Okay.
So before we you know go to other part of code, for the APIs we modified is a create object upload. So basically, you know, added e tag and the partial object parameters to the API. So if partial object is set, right, set to true, e tag must be provided. So that's mainly the you know, the changes for storing, you know, changes in create object upload, you know, for storing a partial object.
Mm-hmm.
So that's that. If no other questions, I can jump on to namespace cache file.
Yeah, I think it's worth it. I mean, we have 10 minutes left for this session, so let's try to do one, maybe one full flow of, so that we can see all the calls, maybe less about the details and more about the flow, and then we can try to see how it looks.
Oops, I changed that again, filters. I don't know how to do a split. Anyway. That's all.
The split view?
Yeah.
With the, yes, with this. split.
Yeah.
And then filter again if you want.
No, it that doesn't work like the. Oops. Ooh. Don't know why. For this specific file, it doesn't do that.
Never. I don't know. Okay.
Yeah. Whatever, and that's probably nice feature of GitHub.
Yeah.
Okay. So let's see which one I can jump on first. Wow. Maybe I should. You know what? Maybe I should view the entire file instead of just doing this. Okay. That probably is much better. Okay. So the flow the code I want to find out first is the two functions. One is range read hop object stream. Okay. Another one is the read hop object stream. Okay. So this function, the first one is basically, what it means like once they reach this API or this function, the read on hop will be range read. Okay. So that's what essentially it does. Then for this one is just performs a generic read operation on hop. Okay. So that function, so this one, so this function is actually a caller of this API, okay, of this one. So it also create a comment. Hopefully it's clear. Okay. So what it does is you're going to have a hop read stream. Okay. Then if it's a range read, eventually once they finish, they're going to pipe to a range stream, because it's the client read, the range read will be different than what we actually get from the hub. Okay? Because what we get from hub is always aligned. Remember that point, is always aligned. Okay? So then, after we read from the hub, we also need to pass a range stream so that we can return the range specified by client. Then in terms of, that's what we return to client. In terms of what we're going to store in cache, so there will be whatever we returned from the hub is going to pipe to a cache upload stream to be stored into cache. And then I have also this this if condition here is, depends on the size of the object. If the size object is small, we're going to read the entire object over instead of read that specific ranges. Okay. So that's what this basic function is. It's going to essentially create two pipes, and then for the pipes we return to user, is the last stream will be a range stream, and there's I create a new class called the range stream class as well, just specifically for return the ranges set by user or set by client.
Can you take us from the beginning of the read and then drill here? So let us see,
Sure.
like even one path, just even like a very specific one.
So let's see, like if for inside read object stream, right? Okay. So this one basically will track this side whether we're going to directly call, the cached read object stream or not. The two conditions is one, whether we have already cached it. If we cache it, this flag says, we have the object cached. And this flag says it's not partial object. Basically, it's we have everything. Okay, you can ignore this one. This one flag is mainly for testing purpose. Okay, so if this condition is true, we have it's an entire object, and also we have those cached. We just directly read it from the cache bucket. Okay. If not, okay. If any of the condition, if it's not true, then we're going to check whether we're going to perform a read rate on hop. Because once we reach here, that means either we're missing data or we don't have the object cached. Okay, so we're going to check whether we're going to really do a hop read rate on hop or not. So if I jump on this file or function, that will be a set of logic to decide whether we do a range rate on hop or not. Okay. So for this one, probably let's see whether I can go through this one or not. Maybe just go through it then, since we already run out of time. Anyway, just go through that. So let's say we have the object cached. Remember, once you reach here, that means it means like we don't have the all the parts. Basically, we don't cache the entire object. So this block, we're going to check. For large object, you'll see whether we should read cached parts from cache or non-cached from hop. Okay, it's kind of a little bit awkward, the wording. I'll read the entire object from hop. Okay, what it means, like if the object is really large, right? And then we cache, let's say 40% of the object already parts already cache 40% the parts in cache, then we can do actually streaming those 40% parts from cache, and the 60 the rest of parts from hop. So this one basically is just going to check whether we should do that or not. Okay. Then some of factors taking into is the number of parts, because there's always overhead in reading a hop, right? If there are too many parts, those parts are disjoint, then we probably don't want to read it from hop, because there will be probably too many reads. Okay, which is we'll have like too much overhead on that. So that's basically this logic going to decide whether we should do it or not. Okay. There's some to-dos.
So what is the number? What is the config for this max cache object size?
So this one, I put it into, I forgot which one. This is a configuration parameter. I think I put it right now pretty small, maybe 4 meg or 8 meg, just for testing purpose. Okay.
Okay.
Yeah. So that's what this block does is used to calculate whether we should do a range rate on large object or not. Okay. Then this part same is not for a large object. Basically, you see if this track will be, say, if it's a size of the object is less than block size, that is I use to check whether the object is small enough. Okay, then going to return false means like we're not going to do a range rate. We're going to do an entire rate. So because the object size is we just read the entire things over. So then again, this one is going to use the let me see, cache the data percentage to determine whether we should read the entire object or do a range read as well. So if the size of read is large enough, okay, we don't have enough data cached, we just read the entire object over, which means, like, for example, we already have 70% of object, 70% of data cached. We would like, we can just read the entire things over instead of, still do a rest of 30% on range read. Okay.
Mm-hmm.
Yeah. So this, this function will decide, whether we're going to do a range read or entire read.
Okay, good. So this this is the decision making, and the intention here is to decide if we do go in range read from the hub, or maybe it's mostly about deciding to avoid the range read, right? So the default, maybe I would say, would be a range read, because that's the most generic sort of way.
Okay.
And here we're trying to sort of prevent waste when we have very sparse caching.
Yeah.
Right. Okay. Okay. So let's stop here, just because I think we will need anyway another session to go through the code. So I think it's a good time to start, and maybe if all the people here can go on, like this introduction to the code, can go on and read the rest of the code before the next session. It will be good to give some comments so that we go through them.
Yep. So next time, next time I'm probably more prepared, because I haven't revisited this code for two weeks now. So, yeah. So I probably also need to revisit, just probably, from my presentation perspective, I can lead you guys, through that. Yeah.
No worries.
Yep.
Okay, you guys. So I'm stopping the recording, and I'll set up a next session in the next, like I suppose Wednesday or something like that, if possible.
Yeah.
Okay.